Here are different charts that you can find on a module spec sheet. The first one is a graph of solar irradiance in watts per meter squared. That's the amount of sunlight measured in a given surface area. Remember, standard test condition is done at 1,000 watts per meter squared at a cell temperature of 25 degrees Celsius. And so this is actually more reflective of a colder day than 25C, because it's specifically done when the cell temperature itself is at 25C. And that's 77 degrees Fahrenheit. So this might be more like a 60 degree Fahrenheit day, not a 77 degree Fahrenheit day out in the field, because the cell and rooftop temperatures are higher than that. Again, you can get rooftop temperature off of PV watts if you want to start identifying what a standard test condition day is in your area. What we see is with more irradiance, our power is increasing. What we also see is even with a little bit of irradiance, our voltage start out with high voltage and low current. And so on a sunny day in the morning, the voltage is still going to start climbing. And when the array turns on and off, it's still going to be operating at higher voltages. It's more the difference between an array performance on a sunny day versus a hazy day is there going to be more or less current, much more than more or less voltage. Voltage starts off high in these systems. Now, where these lines occur, is a subject of temperature fluctuations. So on a cold day, that voltage is going to start up here, and then on a warm day, the voltage might be drugged down by 20%. But regardless, once that irradiance starts hitting the panels, the voltage jumps up much more quickly than the amperage. Here we have a function of cell temperature, and to see how cell temperature impacts current and voltage, as well as their product. Voltage times amperage is power. As cell temperature increases, here we have our power, and our power level. As temperature increases, our power level decreases, so that we can see when the cell temperature starts. This is like right here is a 60 degree day. On a 120 degree day, our power level is dropping by over 20% on a hot summer day. And what we can see is that the total amount across the spectrum that current climbs, it's a much more narrow range than the magnitude of the spectrum that voltage climbs by a rather substantial amount. So it's the voltage that is more impacted by temperature than current, and you can see that on this spec sheet here. And then lastly, we get a voltage multiplied by amperage. And so this chart is displaying power. A volt times an amp is a watt. And we get that power level at different irradiance figures. So 1,000 watts per meter square is standard test condition. 700 watts per meter square would be a hazy or overcast day. 0 watts per meter square would be nighttime when the moon's not up. As far as moonlight goes, as far as shade goes, you need 20% of the sunlight of full sun in order to get these modules to turn on. So, absent some very obscure thin film that activates the voltage at very low light levels, you're not going to get power out of your solar array at night. And even if you did get power out of your solar array at night, that night light only has less than 100 watts a meter square of light to begin with, so there's hardly anything you could convert anyway out of it. We can see how the current and voltage levels will change at different amounts of sunlight, and the power level changes as well. And what this graphic on the right is illustrating is that there's two ends: your open circuit voltage, no power operation at all, and anything in between is how much power the array could be producing. But there is a maximum power point that the solar array could be producing, and it's slightly less than full system voltage. And it's actually slightly less than what full system current would be. If that system is short circuiting, that power is going to spike as voltage is trying to drain down to zero. But operating voltage and operating amperage are slightly less than short circuit current and short circuit amperage.